So we are live on the YouTube as well as on Zoom. Good evening, participants. Welcome to the live session for the course Metallurgical and Electronic Waste Recycling. Our instructor, Professor Arunabh Meshram, sir, along with the TA, Mr. Ankur Srivastava is with us. Please unmute the mic and interact with sir and the TA related to the subject. Thanks.
So I welcome you all to this interaction session. If you have any questions, then I request you to please ask your questions, and we'll try to answer as much as we can.
Arvind, sir, do you have any doubts? Can you turn on your camera?
Maybe I will ask the questions.
So the date of examination is on 4th.
I think
On 2nd. On
yeah,
2nd.
yeah. As far as I know, it is on 2nd, and the exam dates have not changed. I mean, it has changed for some of the courses, but those hall tickets are updated actually.
2nd.
Yes, sir. For our course, examination is scheduled on 2nd of November.
Yes, 2nd of November.
Yes, sir. So hope you have received your hall ticket.
2nd.
Arvind, sir, you have received your hall ticket.
Actually, on 1st of November, there is a Diwali dinner, sir.
Yeah. Yeah. I understand. I mean, that has been the exam dates are scheduled long way back. So
We were just thinking, is it possible to extend at least one day like that?
I'm really not sure about that. I mean, because the
Date
exam
change is
dates,
not possible, sir.
yeah.
Actually, the course is very good, very nice course, and we learned a lot. But just about the exam dates,
So actually, the exam dates for many of the courses are decided at least 2 to 3 years, or so on and so forth, 2 to 3 semesters before we even think about planning the course. So that is how it is with NPTEL.
Yeah. Okay.
And I really appreciate that you like the course. It's our actually motivation that we want to bring in materials recycling and circularity, circular economics, and these important aspects that people should know into common domain of knowledge for people. So this course is devised in that way. We tried to bring in metallurgical waste, which is specific to metallurgical industries, but in general, everybody can really learn. And of course, the e-waste segment is pretty much everybody who is using electronic devices would be able to connect with whatever we are trying to teach and explain in our courses.
Yes, sir. So actually, I would like to ask for electronic waste. We have the option called hydrometallurgical way.
Yeah.
So we are trying to make as a cryogenic treatment with electronic waste and making its powder, and then try to enhance the recovery of the materials from the electronic waste. So just we will be needing your guidance.
Yeah, I'll be sure. Sure, you may contact with me. Maybe my email ID is available in the website. You can connect with me. What type of source are you using?
Using liquid nitrogen We are making a pieces of 5 mm to 6 mm like that for the electronic waste, and then
What waste?
cooling down, and then we are crushing into powder in the ball mill.
Haha. No, so what I'm asking is, what waste are you using? E-waste, as in there are so
We are
many different
using
types.
this computer motherboard.
Yeah, so
random
base printed
access,
circuit boards. Yes,
RAM,
WPC.
RAM,
Yeah.
and all this. So we would,
PCs, ICs, and the WPCBs.
Yeah.
So you are using that.
yes.
Okay. Okay. Right.
So your course was really helpful for us
Thank you so
to
much.
learn many of the things. Yes, and we can make that judgment. I think we should go for hydrometallurgical way for the processing.
Yeah, I mean, if it is feasible, one can try pyrometallurgy as well. But then the process safety has to be kept in mind, because lab scale experiments for pyrometallurgy would require lots of precaution.
Yes,
Hydrometallurgy is relatively more safer, I'd put it that way. And every process has its own advantage and disadvantage. So pyrometallurgy will get a good output, but one has to really optimize what we are trying to do in pyrometallurgy. Similarly, in hydrometallurgy, one has to deal with solutions. What do we do with solutions afterwards is also a very big challenge. Many uh, many research groups are focusing on what to do with spent liquors and residual solid and what's not. So that is one very important area that we can explore.
yeah.
People are trying to do that. I mean, when we look at literature and e-waste, we'll get all of these information.
Yes, sir. Sir, we would like to, when we will do the work, then we would like to invite you as a expert for the judgment, how the things is going on.
Yeah, maybe we can just discuss this beyond this. Yeah,
might have traveled to our city. I don't know, Aurangabad, Chhatrapati Sambhaji Nagar.
Yeah.
We are at MGM University.
Yeah. I'm just looking at the website. So
Yeah.
Nice to connect with you.
It will be very good. Sir, can we get your contact number so that we can call you? And also,
Yeah, you can connect with me through my email ID. It's already in the website. So you can drop an email to me.
email, yes, sir. So email, can you just mention, sir?
I'll just write in the chat question.
Yeah. We'll drop you the email so that you can. So actually, we are going for that cryogenic treatment of the e-waste. Yes, sir. And I think Mukhopadhyay sir or कौन से Mukherjee sir है ना? Mukherjee sir is working there. Sir, कौन? We are following the research paper of C.S. Tiwari sir.
Okay.
Yeah, for the cryomilling.
Okay.
Cryomilling of it. So
Okay.
we are developing that kind of setup, and definitely we need your as a external expert. You can.
Yeah, that'd be nice.
Yeah.
I mean, what we have learned in this course is about pre-treatment and the main routes of recycling. If you can decide what type of pre-treatment you want to do, as far as I can understand, from whatever discussion you have just given me, you are right now focusing on pre-treatment. So If we are good at it with our pre-treatment operations, we'll be doing well with our actual recycling processes. Say, for instance, we do good with pyrometallurgy or hydrometallurgy or combination of these with electrometallurgy to get our finished desired product. So whatever we wish to make or refurbish or reuse, we'll be able to do that. Pre-treatment is very important. So yeah, good combinations and good optimization of each pre-treatment operation that we do, be it regular combination or in your case, maybe if you are trying cryogenic or any other process. So somebody might be interested in, let's say, thermal treatments or any other process. So for instance, somebody might be interested in delamination or any other process. So that helps in improving the overall efficiency of the process.
So, do you think there will be enhancement in the recovery when we make the powder and then try to do hydrometallurgical way?
Powder.
Powder of the electronic waste and then do the extraction. And normal.
So do you want to do cryogenic operation first and then you want to go into?
Yes.
It might help. One has to try and test.
Okay.
That there are some things that we need to try and test, and then we'll be able to
Okay.
comment on such operations better. But in general, it has been observed that if you want to improve leaching or hydrometallurgical efficiency, process efficiency,
Yes.
one has to think on the lines of reducing particle size. So when we have reduced particle size, smaller particles, that means the specific surface area is relatively larger. Specific surface area, not the surface area, specific surface area. So it becomes larger. So the chance of liquid coming in contact with the smaller particles will be higher.
Yeah.
And that really helps us in improving the overall efficiency of the process.
Yes.
So in case we have other participants also, if you have any questions, then you may ask your questions now. If you have any more questions, you can ask.
विचारायचं वाणी विचारला विचार प्रश्न विचारला विचार.
Yeah, Neeraj, you want to ask a question?
Hello, sir. I'm audible.
Yeah.
Sir, when we do the gold extraction, using random access memories and all PCBs are there, na? And when we do the gold extraction, like we have narrated HCl, HNO, the Aquaregia, and all these solutions, we have formulated steps using some research papers that we have read. So now the waste liquid is there. So should we keep that liquid for another extraction of a silver, or for silver again we have to start from the scratch again?
I mean, it depends upon whether we have a good amount of precious metals available in that or not. Many times, whenever we look at whenever we look at the leach liquor of WPCBs, there's a possibility that a plethora of elements will be present with us in the
Yeah. Yeah.
silica. Now, what do we really want to extract?
Yeah.
What is the aim? Whether it is gold, silver, copper, or any other base metal, precious metal, or hazardous metal. There is the categorization.
Yes, sir.
So, what is it that we want to extract? If we are able to use that grind target and do our process accordingly, then we are left with a solution that is devoid of a given metal, let's say M1. Now, a general practice is that if we are able to extract M1 from a solution, whatever metal is maybe your target, it could be a precious metal, base metal, or hazardous metal. You
Yeah.
are left with the whole solution. Then we use it again for the next metal.
Yeah. Okay. So we are actually focusing on precious metals like gold, silver, palladium, platinum from the electronic waste. These are the few that we have listed that we will be extracting. So we'll start with the gold extraction with all the steps that we have said, and maybe sometime we'll also email you to see that whether our steps are all okay, and then we'll showcase you the results of recovery also, that with cryogenic treatment and without cryogenic treatment, if there is an enhancement, so that we would like to share with you. And also then the same solution will be using for extraction of silver and another precious like platinum, copper, or something, palladium.
Yeah, one has to design all of that, all of these processes and the methodologies.
Yeah.
One has to think critically what is feasible and whether it is going to be efficient or not to do the process that we plan to use. Are they good enough for recovery or not? So based on that, we can have that type of judgment and devise the process flow sheet accordingly.
Yes, right, sir.
So I mean, it is advisable that people look at, let's say, various literature from different sources, and then come into some sort of conclusion that okay, fine, we are going to follow such and such route, one step after the other, or something else after the other, and then we can update accordingly.
Yeah. Yes.
Research labs or recycling centers.
Sir, at IIT Kanpur, you have the setup for the cryogenic treatment under your guidance. It is there. We can visit.
Presently, my group is presently into hydrometallurgy actually. So, and we do traditional hydrometallurgy.
Okay, you have that setup.
No, no, we do not have.
Okay, you don't have. Okay, okay.
Any more questions? So, in case there are no further questions, then maybe we can conclude. Will you?
Yes, sir. Maybe we'll wait for a minute, sir.
Yeah.
On the YouTube chat, let's check, and then if we don't have any queries, then we'll close it, sir. So, any exam-related tips you wanted to give it to our students, sir?
Yeah, I mean, if you are planning to give the examination, so the most important aspect would be to go through the content, the course content, look at the lecture videos, the assignments that we have been solving, and the lecture notes that we usually upload along with the lecture video itself. So you can go ahead and follow that. You're also free to explore as much as you can from different sources in the internet or any other book that you would like to follow. And all the very best you for the examinations.
Thank you so much, sir.
Sir.
Ankur, would you like to tell something
Yeah.
to our students?
So it was very fantastic, this one, and because of that we could make that a research as a research project. We have converted this learning into the research project. Now we are working on this, as I have told, about various setup, hydrometallurgical, cryogenic treatment, and into that this course was very much helpful for us for learning. I would like to know which are the various research lab which are conducting this hydromet.
There are many. Actually, there are many.
So that we can visit one or two.
Yeah, I mean, most of the premier IITs and NITs are now focusing on metallurgical and materials recycling. So if not traditional metallurgical wastes or electronic waste, they are doing something else. But there are many groups. CSIR labs are also doing. They are leading actually. So yeah.
Which ones are CSR lab? Which one? Any exact?
NML and IMFT and so many others are also doing.
Okay. Okay, sir. Okay.
Ankur, would you like to tell anything before concluding?
Yes, in my opinion, the course has been designed for the students to explore as much as to grasp the knowledge about the waste recycling. So the professor has already covered so many different type of the waste, such as e-waste or metallurgical waste, as well as he also has some in video lectures. He has also covered some plastic waste. So all the wastes and the initial level of the required knowledge for the recycling of a particular type of waste, which is essential before developing a strategy. Is required. So the professor already has covered, and I hope that students have enjoyed this course a lot and they have learned a lot from this course. And if they have any queries, even after the conclusion of this course, they can contact us. So that's all from my side, and all the very best to the students for their examinations. Thank you.
Thank you, Ankur. Sir, can we conclude the session now?
Yeah.
All right, sir.
Thank you. Thank you very much.
Okay. Thank you, sir.
Thank you, Ankur. Thank you, Dr. Arunabh, for joining.
Thank you. Thank you, sir. Thank you.
Yeah, thank you.